GeopByte.
Let us take the another important problem. Asking like this. A ball of mass 0.15 kg is dropped from a height of 10 meters, striking the ground and rebounds to the same height. It is like this. Let us take the ground. This is the ground. A ball is available. This is the initial position of the ball. Let me draw it clearly. This is the initial position of the ball. That ball is available initially at a height of h equal to 10 meters. It is moving towards the ground, hitting the ground, and it is rebounding to the same height. It is rebounding to the same height. It means the body is traveling. The body is traveling towards the ground with a velocity v, and for having the same rebounding height, it must be hitting and leaving from the ground. It must be hitting the ground and leaving from the ground with the same velocity. Okay, then only it can be rebounding to the same height. Then what we are asked to find the magnitude of the impulse imparted to the ball is. You are asked to decide what is the impulse imparted to the ball. For that, first let me decide the meaning of impulse. As you know, force F equal to mass times the acceleration. F equal to mass times the A equal to what? dV by dt. dV by dt. From this, I can write that force multiplied by dt is equal to mass times the dV. Dear friends, remember the product of F and dt is the impulse. Is the impulse. That impulse equal to what? Product of mass and change in velocity. So anyhow, impulse equal to product of mass and change in velocity. But general formula, product of the force and time is the impulse. Right? Now it is m into it is reaching to the ground with a velocity v and leaving from the ground with a velocity v, but in opposite direction. It is v minus of minus v. Understood clearly? Yes. It is m into 2v, v plus v, 2v. It is 2mv. Okay. Otherwise, let me write another step. M into v plus v. So, mass is given, but we need to decide the velocity. Velocity v equal to what? Root over 2gh. Root over 2 into g given. Look at the g value given 9.8. 9.8 into height given is 10 meters. Height given 10 meters. 10 meters. It is equal to root over 19.6 into 10. It is equal to root over 196. It is equal to root over 14 whole square. The square part, root part cancelled. V equal to 14 meter per second. Therefore, impulse equal to 2 into m is given 0.15 kg. M is given 0.15 kg into V 14. Simplify this value. It is 0.3 multiplied by 14 equal to 4.2. Look at the units. Mass is in kg, velocity meter per second. Kg meter per second. 4.2 kg meter per second. Look at the option C. Option C is absolutely correct. Understood clearly? Yes. Similarly, look at the another important problem. It is asking like this. Three identical spheres, each of mass capital M, are placed at the corners of the right angle triangle with mutually perpendicular sides equal to 2 meters. Look at the three particles. These are particle 1 of mass capital M, particle 2 of mass capital M, and particle 3 of mass M. 1, 2, and 3, these three particles are connected, right, such that it is forming like a right angle triangle. Right angle triangle. Okay. Now, each side distance 2 meters. 2 meters. Then, taking the point of intersection of the two mutually perpendicular sides as the origin, right? So, that means indirectly this is the origin. Origin. Wherever the two mutually perpendicular lines are meeting, that is the origin. He is asking once again, taking the point of intersection of the two mutually perpendicular sides as the origin, find the position vector of center of mass. That means you are asked to decide position vector of the center of mass. For that, we need to decide the center of mass about x-axis and y-axis. First, let us decide the m1, m2, m3. 3 are equal, that is equal to m. Look at the x1 equal to x2 is equal to 0 meters. But x3 equal to 2 meters. Look at the screen. Similarly, y1 equal to x1 equal to oh no, x1 equal to x3. 1 minute. Be very careful. x1 equal to x3. x1 equal to x3 equal to 0 meters. This is the x2. This is the x2 2 meters. Similarly, y1 equal to y2 equal to 0 meters. But y3 equal to 2 meters. 2 meters. Let me write another slide. m1 equal to m2 equal to m3 equal to m, x1 equal to x2 equal to 0 meters, but x3 equal to 2 meters. Is it correct? x1 equal to x3 equal to 0 meters. Should be very careful. x1 equal to x3 equal to 0 meters, x2 2 meters. Sorry. Similarly, y1 equal to y2 equal to 0 meters, y1 equal to y2 equal to 0 meters, but y3 equal to 2 meters. y3 equal to 2 meters. Now let us decide the center of mass about x-axis and center of mass about y-axis. Here it is m1 x1 plus m2 x2 m1 x1. Let me write it clearly. m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m. Okay. Here m1 m x1 is 0 plus m2 m x2 is 2 plus m3 m x3 is 0 divided by capital M plus capital M plus capital M. It is equal to 2m by 3m. Finally, it is equal to 2 by 3. Similarly, center of mass about y-axis. m1 y1 plus m2 y2 plus m3 y3 divided by m1 plus m2 plus m3. m1 m y1 0 plus m into y2 also 0 plus m into y3 2 divided by m plus m plus m. Here it is also equal to 2m by 3m is equal to 2 by 3. Therefore, position vector equal to position vector equal to 2 by 3 I cap plus 2 by 3 j cap. That is the position vector of the center of mass. Look at the option. Okay, this can be also written as 2 by 3 into I cap plus j cap. That is also other way to write. Look at the option C. Option C is absolutely correct. Understood clearly? Yes.
GeopByte.